Great.
Yeah,
Good morning again. That was an awesome 3-minute session. Very impressed by all the folks who joined that. I'm Bruce Chamberlain, energy manager at Berkeley, where we dabble in all things commissioning. And an alternative subheading for this session could be, and then there was OCX. So we before we dive in and I introduce these esteemed professionals, I wanted to just refresh a couple things. I'll go to here and you'll see the faces. A couple terms. Commissioning, was the first the overarching term and practice, and that's a quality assurance process that verifies MEP systems are installed, tested, and operating per design intent. And then my cat has joined us. Perfect timing. Um, and then we have DX, which is has taken on a couple different, if you want to get into the weeds, there's retro commissioning, which is commissioning a building that never had commissioning. So retroactively commissioning that building, and then recommissioning, which is going back to a building that already had commissioning. And as USCOP is developing some excellent guidelines, there's monitoring-based commissioning, where kind of is initiated in utility programs and then is used. I'm sure there's people on this Zoom that are using monitoring-based commissioning, and UCOP guidance is going to be coming out soon in tracking building energy performance in the terms of EUI. And so from there, evolving an ongoing commissioning practice. And now to this acronym, we add EME, which is Energy Management NV. And no, just kidding. That is not a new acronym. That is just my take on my reaction to the OCX efforts and programs that these next three presenters are going to share with you. And as you'll see in here, while there are similarities between these OCX programs, each of these campuses have journeyed on unique paths that are tailored to their own energy management world. Some commonalities you'll hear are a dedicated in-house team with complementary skills, developing a backlog of short duration work items and potential for savings, driving a regular and repeated process, calculating savings, of course, and monitoring using data analytics tools to ensure savings are maintained over time. So with that being said, hopefully that sets the stage. Let's meet the panel. We're going to go in order of Irvine. You see Irvine, and then you see Davis and LVNL. And they're going to talk about 10 minutes each, and then we'll do Q&A. And kicking it off, I'll do the intros now, and then we can just go through the presentations and do QA. Joe Fleshman, who you've heard from already today, is a professional engineer and the director of energy and engineering for the University of California, Irvine. Joe acts as campus energy manager, provides construction engineering support, and manages the building automation department. He uses current priorities, including building commissioning, energy metering and sub-metering, and decarbonization. Following Joe will be Hiroko Masuda, and she's an energy project engineer at UC Davis Facilities Management, where she leads efforts to improve building performance through HVAC systems, analytics, and energy efficiency programs. Before Davis, she spent over a decade at Energy Systems Lab at Texas A&M, where she earned her master's and PhD in mechanical engineering while working on data analysis, measurement, and verification and commissioning. Her career in energy management began in Japan with Johnson Controls when that company expanded into energy efficiency field back in the early 2000s. And Chris will wrap up the three presentations. He is a control systems engineer at LVNL with over 20 years of experience in the HVAC controls industry. As a member of the Sustainable Berkeley Lab team, he leads an ongoing commissioning program dedicated to maintenance and optimization of building automation systems. Chris is a certified energy manager, professional control systems engineer, studied electrical engineering at University of Minnesota and data science at UC Berkeley. So with that, I am going to stop sharing. There we go. And Joe, can you share? There, I think we got it.
All right. Thanks, Bruce. Appreciate the handoff. Thanks, everybody. Operational commissioning or ongoing commissioning, we call it operational commissioning here at UC Irvine. I mentioned in the last section that we have had a very aggressive energy efficiency program over the years, and we use operational or ongoing commissioning as a way to try to maintain those savings, right? So the buildings have been tuned up. We want to keep them tuned up. So from our perspective, which is a little different from some of the other folks you're going to hear today, our prerequisite here was we retro commissioned a lot of buildings, right? So we spent the time to tune the buildings up, to get the buildings set up where they're already energy efficient. We've established baselines. We've set a good starting point. And we've done that really across 28 buildings in the last 10 years, primarily being laboratory buildings. So we have a large portfolio of buildings that have been tuned up and really sort of prepped for the OCX process. One of the things that we do, we also use SkySpark. We integrate our data down to the zone level for all of our retro commissioned buildings. So, you have laboratory buildings with, variable air volume, supply and exhaust and fume hood valves. All of that data is pulled into SkySpark, and we can use that to continue to keep an eye on how the buildings are operating and make adjustments as necessary. We've also integrated meter data like hydronic, that's chill water, high temperature water, electric, gas, for other buildings where possible. So we have some form of data collection at 135 of our buildings, which is the vast majority of the campus core buildings. We also do have 1 minute data resolution for our critical infrastructure. So like our cogen, 66 kV substation, voltage, kVA, power factor, all of that stuff. We keep that at a much higher resolution because sometimes things can happen really fast on those critical infrastructure sources. So for us, the OCX approach really works because we've already retro commissioned those buildings. So think of it as we did the deep building level dive. We got the equipment working properly. We got the resets in place. We got the schedules tuned up. We got everything working properly. Now, when we move to OCX, since that work's already been done, we're now, instead of looking at our sort of narrow and deep analysis, we're looking at a wide and shallow analysis. It's like everything was working. We just need to make sure that it continues to be working. And so we're focusing on keeping good operation, keeping things from going out of spec. So the types of things that we do during a retro commissioning that we're really trying to keep an eye on in the OCX are things like schedules, resets, and economizer operations. So our process is really different than a retro commissioning, because a retro commissioning, typically you have maybe a 12 or 18 month project. You come in, you go into every single bit of the building, every room. You're really focusing on zone level, really detailed, actuator level items, and getting everything tuned up. And so you have construction associated with that, and a lot of extra programming that maybe wasn't present or wasn't optimized. In this case, instead, what we're doing is more of an iterative process. So we have a consultant that helps us. That's our SkySpark vendor. They basically create new findings on a biweekly basis and meet with us. So I, as the energy manager and project manager, can review and assign those to my building automation team. So we meet on a biweekly basis. I generate work orders, assign them to building automation. When those work orders are completed, we turn that back over to the consultant for back check. And involved in those biweekly meetings, we do include our energy efficiency rebate program representative, so that we're feeding them live data of, this has been fixed, this has been fixed, this has been fixed, and then they can perform calculations on the back checked items for incentives. So on the right here, we have an example of sort of an issue tracker. There's a heating hot water valve stuck open when it was identified, what the evidence is. And through SkySpark, you can actually click through and go straight to the graph that shows this abnormal behavior. So, I can validate it, my team can validate it, and know exactly what they're looking for. So some of the examples of results is holiday scheduling. So we look for some scheduling opportunities during the holidays. As you can see in the top right, in the 23-24 holiday season, we had a lot of air handlers that were running 24/7. even though the campus really shuts down from about December 15th until after the first of the year. So one of the things that I did was to work with the building managers to approve more holiday schedules, make sure that the buildings that could, that we thought could be scheduled would be acceptable to the building to also be scheduled. And when we got that approval, we went and then ahead and implemented these holiday schedules. And you can see in the bottom right how almost every building, in this set of charts is now scheduled. And so that's just basically free energy savings. Economizers. So we identified lockouts or damper problems at 15 air handlers. This is a pretty common problem where we are. We're close to the coast, and so outside air dampers tend to freeze up, especially older galvanized steel ones. That the moist, kind of sea water type air will corrode those. We closed out all 15 of those. We improved the economizer operations. We've added some additional fault detection for additional economizer opportunities, which I'll talk briefly about later. Supplier static pressure and supplier temperature resets. Sometimes it's a simple rogue zone that goes out of whack, or sometimes someone overrides a set point because they got a complaint inside the building. Through this OCX process and this sort of 2-week iterative process, we can identify those things and get on top of them. Once we figure out what is actually causing it, because sometimes it's not as simple as an override. So we had a couple buildings that had static pressure reset issues and 8 buildings that had SAT issues, and we resolved a couple of those static pressures and some of those supplier temperature resets. What often happens, though, is you have rogue zones, and you have multiple rogue zones that you have to get the people out in the field to repair and operate properly, and those take a little more time to resolve. Our year 1 results, we saved almost 500,000 kilowatt hours that would have otherwise basically we would have lost those savings that we had achieved during retro commissioning, because we've been able to keep those and persist those kWh savings. 91,000 therms and about $240,000 that I would have otherwise spent on the energy bill. So some of our challenges. Our program is structured, like I said, it's not a long time quote unquote construction project. Instead, it's an agile Scrum-like approach. So we're doing this iterative cycle every 2 weeks, and it took a little bit of time for us to sort of figure out the cadence that worked best for us, right? I only have 4 automation guys that do 6 or 7 million square feet. And so what we found at the beginning was the consultant was finding way more items than we actually had the capacity to tackle. And so then, we started off with a weekly cadence. That was too fast. And then we switched to monthly, and that was too slow. We tried every 3 weeks, and we ultimately settled on a biweekly cadence that was enough where we could get some wins and they could bring us new items, but it wasn't, it was more balanced in implementation. That's what worked for us based on our capacity. For you, you might have to go through the same experience to really figure out the cadence that works best for you. As I mentioned, we have some resource constraints, as everybody does. Our building automation team is limited. I have 4 staff and no supervisor right now. So I'm the supervisor. And so we do what we can, but hot, cold calls, major operational issues, an air handler goes down, like those take priority over energy projects, which is a constant push and pull challenge that we have on the operations side. We also, as I kind of mentioned earlier, our more complex findings took substantial amounts of time, or take substantial amounts of time. So most of the wins that we had in year 1 were really those items that took 4 or less hours, right? It's fixing a schedule across the building. It's, going out and, lubricating the economizer and replacing an actuator, like things that were pretty easy and quick to do, were where most of our first year wins came from. We have just started year 2 in our OCX process, so it's a relatively new process for us. And so a couple things that we're changing and sort of as the program evolves is that we're splitting off what we're calling special projects that are broadly applicable on campus, right? But these are things where, you have older buildings that may not have DCV control, or their CO2 sensors don't work. And you're like, oh, okay, if I update my demand control ventilation scheme, this is actually applicable across dozens of lecture halls across campus. Let's sort of separate that off and tackle that as its own sort of animal, instead of, and maybe I can assign a project manager, or we can bring a consultant in to sort of cookie cutter, copy paste, make those changes. Like I mentioned, we're near the coast. And so one of the challenges that we have is on really humid days, a dry bulb economizer lockout isn't sufficient because we basically dump tons of humid air into the building. And so we're looking at supplier temperature limits based on dew point, economizer lockout based on dew point. And then like one of the last things that we're challenged with is that the building startup heat load really hits the central plant hard, and that's a challenge for the plant to manage. We really want to flatten that heating load in the morning out. So those are some of the kind of special projects that we're going to keep an eye on and work on through this OCX, in addition to all the things I mentioned before. And then we're going to refine our process for establishing clear scopes and tracking work orders to completion. The ARC system, is a way to have a central database, but I have some challenges getting that kind of into a work order system in a way that's easily trackable. And so we're going to work on improving that, and then expanding our automated fault detection capabilities in SkySpark. So thank you very much. I hope that was informative.
Informative and nailed the timing. So well done once again, Joe. Thanks so much. And I'm sure we'll cover some questions, come back to you on those. But let's see, can Hiroko share her screen at this point? Excellent. Suspense building. Go right ahead whenever you're ready.
Okay, hold on. Let me adjust application.
We'll pick a slide. Yeah, there we go.
Okay. Can you hear me? Is it good? Good morning, everybody. I'm Hiroko Masuda from UC Davis Energy and Engineering. And our team manages a range of ongoing programs that keep campus buildings performing efficiently and reliably. While this session focuses on ongoing commissioning, we don't follow the formal ongoing commissioning process exactly. Instead, we apply those same ideas through various programs that continually maintain and improve system performance. In the early 2000s, there was an IEA Annex 40 formed for commissioning of building HVAC systems for improved energy performance. So they define the ongoing commissioning is a commissioning process conducted continually for the purpose of maintaining, improving, and optimizing the performance of building systems after initial commissioning or retro commissioning. I actually attended one of their meetings in 2003 in Kyoto when the commissioning glossary was still being debated. I was still brand new to this field and I wasn't sure if I'd even stay in it for a long time. It took several years to understand how important the goal truly is. Now, through our programs at UC Davis, I can see those same concepts in practice every day. So our approach isn't a formal ongoing process, but it shares the same intent to resolve operational problems, improve comfort, optimize energy use, and recommend retrofits when needed. Here's a quick overview of our ongoing programs. HVAC scheduling means daily, weekly, and seasonal adjustments to equipment runtimes. We keep base schedules short to save energy, but extend them on demand for events or special requests, so comfort isn't affected. Automated fault detection uses building automation system data and SkySpark analytics to detect inefficient control logic or equipment failure early. Thermostat gathers occupant feedback. People report hot, cold, warm, chilly, or neutral, and we review each of them, each entry alongside with building automation systems data. And many reveal control or equipment issues we wouldn't otherwise notice. We also support operations directly, for example, by sending custom email alerts so controls operators know when an HU fan stops before occupants call them. Together, these programs improve comfort, reliability, and energy efficiency across the campus. Our team was formed in 2015 and has been funded by energy savings verified through campus energy meters. On this chart, the blue bars show annual savings, the orange bars show annual investments, and the line shows our cumulative balance for the past 10 years. Early on, we focused on retro-commissioning large laboratory buildings, creating the initial savings that kept the team going. Since FY 2021, we've consistently saved more than we invest, and we brought our cumulative balance positive after FY 2023. Those savings are reinvested into tools and new programs. When I overlay our programs, like milestones, you can see that the evolution of our work aligns with our financial recovery. So starting in 2015, we launched RCX for lab buildings, and the thermostat was there from the beginning, but recently we expanded that with student interns and more involvement by the energy engineers and controls engineers. And around 2017 and 2018, scheduling effort came in. And we introduced the opportunities log around 2018, which identifies energy saving ideas from conversations with maintenance staff or lab managers, or simply by looking at building automation systems graphics, then implements and measures the impact. We also started Swarm, which upgrades HVAC systems in smaller buildings with internet-connected thermostats, so we can monitor and schedule them remotely to save energy. And automated FDD using SkySpark came in 2020, and we expanded that effort recently. And we also started getting involved into warranty period monitoring commissioning. And finally, like this year and last year, we started SkySpark more operation purposes. Over the decade, we've evolved from discrete energy projects into integrated ongoing projects. As we've expanded, collaboration has become essential. This diagram shows the many teams we work with, both inside and outside facilities management. For thermostat, the interface and occupant communication are managed by user experience expert, and student interns triage feedback with help from energy and controls engineers. An HVAC scheduling request starts with a customer support operator who receives a request from a campus customer and coordinates with energy engineers to implement it. Lab ventilation optimization brings together energy engineers, EH&S, lab users, and the maintenance shop, walking the lab, adjusting controls, and confirming both safety and efficiency. For measurement and verification, a data scientist builds models and validates meter data in collaboration with the utilities instrumentation team. Each collaboration combines different expertise and perspectives, allowing us to tackle new problems and challenges effectively. Students are essential members of our team. They help with data review, diagnostics, and documentation, directly supporting staff engineers. Training them takes time, but explaining our work helps us see it more clearly, and students often give valuable feedback. We maintain several students at once, so experienced ones can mentor newcomers. It's like our two-year cohort model. And over time, we have created a strong library of training materials and a lasting culture of shared learning. Looking ahead, We are focusing on 4 main areas: supporting the UCOP's 2% annual energy reduction goal through our ongoing programs, establishing a monitoring and correction loop so our RCX savings persist. It's like a true ongoing commissioning process. And applying lessons learned to new construction projects. And finally, building an HVAC knowledge base for engineers and technicians. These initiatives will strengthen our culture of continuous improvement and make it easier to sustain performance across the campus portfolio. We began with a focus on energy savings, but over time, that work has grown into something very broad. Continuous improvement has become part of how we operate every day. So it's no longer just a project, it's a culture. Our team may look different in 10 years, but our goals will stay the same: energy efficiency, comfort, and reliability. That's what drives us forward. Thank you.
All right. Thank you, Hiroko. That's excellent. Great visuals, great information. Now we'll bring in Chris as he shares his slides. It looks great, Chris.
All right, thank you. I manage our ongoing commissioning program at Berkeley Lab. We are a Department of Energy national laboratory that is operated by the University of California. We have a 2,000 square foot campus and also have 4 controls technicians responsible for all of those buildings. We differ fairly significantly from UCI in that we are commissioning our buildings often for the first time or for the first time since they were originally built. So we are not starting with a clean baseline, which is why we developed this process that allows us to continually identify and select new energy and water wasting deficiencies in our buildings, promptly fix those deficiencies and verify that they were properly fixed, and calculate and, most importantly, maintain accumulated savings, which I'll get into a little bit later. But our goal is to identify and achieve a new 400 kilowatt hours worth of savings every year, and to make sure that we don't lose those. We continue watching the buildings and identifying any new problems that might be taking away from those savings. Ongoing commissioning is also the core of our Smart Labs efforts, which I'll mention at the end of my presentation, but has been a very good community for us to participate in as we've gone through this journey. The key elements to our program are based on Scrum as well, which you can see a book at the top of the screen there that I did not read, but my boss did, and he told me what it said, and we developed the program based on that. We also have a paper that clearly defines this process on our website at ocx.lbl.gov. Our team is a cross-functional and dedicated team, which I think Joseph also mentioned in his presentation. The dedicated portion is very important to our productivity and making sure that we get consistent results through every monthly cycle of our sprints. Those repeated cycles start with us identifying new deficiencies, generating a backlog, breaking those things down into tasks that can be achieved within a 1-month period, and then spending the entire month resolving those deficiencies. We check in every single morning via Zoom. It's generally meant to be a 15-minute check-in, but one of the important questions that we ask everybody in that check-in is, what do you need help with? And so we often identify areas where other team members can assist with resolution of issues. During that period of time, it's very different than our typical work order process. We have we assign tasks to everybody in the team and give them the entire month to work on them. The typical work order process for us would be that a technician would be assigned a list of tasks every morning and expected to complete them by the end of the day. And if they're not completed by the end of the day, there often isn't necessarily follow-up on those issues. We do not close any work orders until the team has fully completed everything that was required of them in their task. And then we sometimes actually reopen deficiencies if they don't make it through the verification stage. At the end of every sprint, we have a retrospective with the entire team, which gives us a chance for everybody to talk about their wins and their challenges and identify new areas where we can improve in our process. And the fifth element is the tools and process to maintain savings. So the process is essentially outlined in this flow diagram here. Our core team, actually I need to update this diagram. It's now 5 people. We've added an energy management engineer to the core team. And we get a lot of support from the rest of the sustainability team and other partners in facilities management. The tools that we use, primarily the tool that we use is SkySpark, and that has been a real game changer for us as we've been able to integrate almost every single operational system across our campus and combine all of that data into a consistent platform where we're able to analyze and document all of our work. Our team currently, like I said, we have 5 people on our core team, 2 controls technicians who are also members of our general facilities controls team. And we recently added a new energy management engineer. Raphael manages our SkySpark instances and does all of the custom programming and development on those systems. And again, we have significant support from the rest of our sustainability and operations teams. And we've had 12 student interns since 2018. Some of them do stay on for extended periods of time, which is fantastic. They provide a lot of support for our process. And it's been very rewarding to work with these students. Some of the types of things that we work on, going through buildings that, some of our buildings are constructed in the 60s and 70s. We also have quite a few newer buildings. We very regularly find that basic HVAC system maintenance generates significant savings. So fixing failed valve and damper actuators, dirty airflow sensors is actually something that was sort of surprising to us, where we've realized that on exhaust air systems, where we use hot wire anemometers for monitoring airflow, we find these systems can get very dirty and underreport the amount of airflow. So we actually can dramatically increase the air change rates in our buildings due to dirty sensors. All it takes to solve that problem is a Q-tip and some isopropyl alcohol, and they generally work just fine after that. Scheduling issues, that has been a very significant challenge because going back into laboratory buildings and trying to change the environmental conditions involves discussing the requirements of scientific apparatus and experiments with a lot of different people and getting their buy-in before we can make changes. We also regularly update the sequence of operations for the control systems in our buildings. We use SkySpark to identify when we have set points on our HVAC systems that are inappropriate. Either we're overcooling or overheating spaces. And also we spend a lot of time addressing poor or missing data, especially with utility meters. Over the course of the past 7 years, we've executed 95 sprints and a little over 1,800 deficiencies closed. This chart shows cumulative savings from our various ongoing commissioning and retrofit efforts. So the red bars are the savings generated by the core OCX effort. And we like to look at this in a cumulative manner because the goal here is that we find at least 400,000 kilowatt hours of new savings every year, and we don't lose any of those savings over time. So at this point, we're up around 7 million kilowatt hours annually that we are maintaining through our standard OCX process. So this chart I'm going to spend a little more time on because it kind of illustrates the effect of continuing to work on a building over time. In 2017, Building 67, which is our largest laboratory building, was also our highest energy consuming building. After 7 years, we've got it down to the 7th highest energy consuming building, resulting from a 56% reduction in natural gas consumption. And we started in 2018, and we basically spent three or four people working on this building full time for between 6 and 9 months, I believe, in which period we replaced, I guess it looks like a year, I guess, based on these dates. We replaced nearly a third of the actuators on hot water valves and VAVs in that building. This building was only built in 2008, so it's not one of our old buildings. It's one of our newer buildings. But because of poor tuning and maintenance on the HVAC systems, we had very significant rates of failure. After performing those repairs and updating some sequences to add resets to the air handlers, we had achieved a 21% natural gas reduction in that building after completing 292 work orders. We went through the effort of adjusting schedules and further tuning the controls in our laboratories. So in 2021, we had then completed 346 work orders and had gotten up to 32% savings. We added further schedules to labs, which I mentioned earlier was a fairly significant challenge. Those schedules got us up another 7%. And further efforts, basically every month we go back to this building for 2 to 4 new issues that we've found. And as we've gone through further tuning of our systems, further adjustments of schedules, and in some cases adjusting airflow rates that were far above the requirements, we eventually got up to 59% natural gas savings. Now we've lost some of that over the past year due to some failures in our chiller plant, which is actively being worked on. But the red lines, the red bars on this chart show the actual natural gas consumption over time, and the gray bars are weather adjusted baseline based on when we started in 2017. So this is something that we love to show our technicians when we do our retrospectives at the end of every sprint. It's very rewarding to see these kinds of results. I mean, they've completed 514 work orders in this building over the past 7 years, and the results are quite significant. It's really does a lot to motivate our team. And one other thing that we've sort of taken on as a result of our efforts, because we are paying so much attention to our laboratory buildings, and because we've recognized that we can achieve significant energy savings simply by making buildings work the way they were designed. We don't have to do major capital projects. We don't have to make significant changes to the sequences of operation. We really just need to keep them working the way they were designed. One thing we found is that we are regularly finding issues that could potentially result in safety concerns. We have many fume hoods. We have lots of labs with pressure controls, whether they're clean rooms or chemical labs. Those pressure controls are very important, and we found that by monitoring systems with a priority based on safety, we're able to get better buy-in from the building managers and the folks in our environmental health and safety department. And we also have found that we have customers, the PIs that are responsible for these labs, that are very appreciative of the proactive efforts that are being made to resolve deficiencies in their buildings. So I think John mentioned earlier, we are now looking into some more efforts to collaborate with our facilities teams, such as condition-based maintenance, and hopefully we'll have some great results to share from that next year. Thank you.
Excellent. All right. Thanks, Chris. We're rounding out the 3 different journeys that your campuses have taken on OCX. We can dive into some questions. I have a couple of as a joint, but there is been a couple questions here. There was one question about building envelope commissioning, which is kind of a bigger separate category of commissioning, and folks can respond to that. Different campuses if they want. But then another question from Patrick was are there metrics LBNL has on the percent of total building savings for electricity, natural gas, and water? And thanks, John Elliott, for pointing to links for savings for building. And then Patrick followed up with, can you speak to the tuning of sparks as you have fleshed out this commissioning program? And I guess that could be for Chris and or Jeff. Chris, do you want to jump in on that?
Well, I'll say one thing I kind of skipped over was that when we started this program, because we were not starting with buildings that had been retro commissioned and were working well, because we had gotten a lot of information from Anna about her experiences with attempting to do SkySpark many years ago. We didn't use Sparks for the first several years of our program. We used SkySpark to collect data and to create good visualizations that helped us find problems. And then we started deploying Sparks after the buildings were working correctly. Primarily, the only sparks that I really pay attention to are the safety sparks, which are actually quite simple. They're not much more complicated than the alarms that you would have in a BMS, but they are much easier to view in the charts than they are in alarm logs on a BMS.
Great, thanks. Joe, any thoughts on tuning of sparks?
I would say that, we use Altura as our commissioning provider that manages the SkySpark instance. And so they do any tuning of the sparks as part of our OCX. So, normally when we do regular retro commissioning or monitoring based commissioning, the sparks really drive sort of opportunities within that. What they did as part of our OCX was some of the graphics that I showed where it's like fan status or static pressure across like multiple buildings across like a week's worth of time. were basically kind of custom views using those existing sparks and existing data to really to do that sort of broad and shallow look across campus. So we do, I mean, we do have a lot of sparks enabled, but I personally don't have the time to really touch every single spark. Part of our 2-week, biweekly cycle is that they bring to me, hey, here's your high priority items. Here's the things that we think are the most, costly items from the spark. So they do the behind the scenes and then present me with actionable. I actually worked with them closely of like, here's what I want work order language to look like so that I don't have to rewrite your finding, so I can put it into our work order database. And that was part of that sort of growing and learning process over the past year.
Yeah, it's great information. Just a quick follow-up. So we're doing it in-house, kind of like LB&L, and I was aware of that kind of, Joe. That's the service you pay Altura, right?
Yeah.
For the tuning. But there's this fine line between spam sparking and not catching enough, right? And I know, Joe, you're nodding because I can tell you've been doing it long enough, and that's what Altura does, right? Because they filter out. But it sounds like, Chris, you're dealing with that hands-on, or you have someone on your team who's kind of filtering that fine line between over sparking and missing stuff.
Yeah, absolutely. Raphael, he tunes those per building. He adds custom tuning on certain sparks so that they will not trigger as frequently. So we try to get it down to where if I open up a page of sparks, I shouldn't have to scroll, right? I should have a pretty small list to process. Otherwise, I'm never going to get through it.
Are you getting cost numbers too? Have you built either of you fleshed it out as Altura, like to prioritize not by duration but by cost? Because that's a feature, but it's a little complicated to implement.
We don't use cost in our sparks, but we have implemented prioritization based on different factors that influence safety. So we're able to sort by which are the highest priority safety concerns.
And Joe, how does Altura prioritize for you? Are you doing that prioritization?
I will do, so they'll bring me basically a collection of arcs and they will categorize it from their perspective as like low, medium, high. And then I will prioritize based on the sort of financial impact and also capabilities in-house, staff availability. Unfortunately, because of the, limited staff that we have, sometimes I have to sort of set aside like, okay, I need to scoop up a bunch of this stuff so I can go to a consultant or a contractor to do the things that I don't have the in-house ability. So part of my responsibility is they bring me a basket of arcs and I have to select from that and then dispense it out for my guys to process and report out that they've completed it.
Thank you so much.
Can folks hear me? I heard
Yes.
there was a mic issue, but oh, great. Thanks, Patrick. Yeah, great feedback there. Going to Maria's question and curiosity about how often the thermostat data is relied on to optimize building temperatures given certain constraints in building temperature ranges and inconsistencies between temperatures in different rooms within a single HVAC zone. That would be a UCD question.
So this question is about thermostat. Correct.
Correct.
So thermostat is like a feedback and it's coming from individuals, and we don't use it for optimizing building temperatures, but we try to figure out why it was warm for that person. And for example, if there are 3 warm complaints from the same room around the same time, that sounds like something is wrong. And we can dig into that and why it was happening and when it was happening. We use also SkySpark and building automation systems and everything. And then sometimes we can find the real issues, like a cooling loop isn't opening up the dampers actually, or something like that. So that's one thing. And Something else is like a seasonal temperature adjustments that happens a lot. For example,
Hmm.
during the winter month, it was a little too, the temperature set point was set to warm, but when the spring arrives and summer starts and that temperature set point is getting too high, and we can adjust those temperatures. So I don't know if I can call it like optimization, but from comfort point of view, that may be like optimizing the comfort for the larger amount of people. But thermostat, there's like one or two thermostats for like a big lecture room. So I don't think it can represent everybody's feeling. But if we can listen to people's feedback, we can make it better than just looking at thermostats on the wall. So that may be considered to be optimization. And one interesting thing about it, so we use SkySpark a lot, and I intentionally didn't mention it because the two other presenters have really good examples, and I knew about it. So the zone temperature sparks, we get sparks, but if we have like hundreds of rooms above temperature set point, below temperature set point, we don't know what's the prioritization for that. But if we get thermostat feedback combined, we know that's the real high priority zone. People are suffering. So we do combine those two different things like sparks, and also thermostats, and we use all the possible information to improve comfort.
Great. Thanks, Hiroko. I think that's the ones I've seen. If anyone's seen, I'm going between chat and Q&A. I haven't seen any Q&A for a while, but people are asking in chat. I'll pose something to the panel to kind of pick up on Chris's excellent comment regarding safety and the co-benefits of an OCX program, and brought up EH&S as a partner. Could maybe, well, Chris, or why don't we go to Joe, since Chris, you mentioned safety, and share any co-benefits beyond your initial purpose or goals of the OCX, that as you came along in the process, you realize, oh, wow, we're picking up additional co-benefits, we're building better partnerships, and that. So can you speak to that, Joe, and then Hiroko and then Chris?
Yeah, I would say one of the advantages of the OCX process is that we can catch things before the users call it in, right? So, before you get the hot cold call, if you're catching, because sometimes, people deal with a temperature issue for a couple days or whatever before they complain. By having the biweekly scrums, like, you can identify things that might be impacting the building users that you just haven't heard about yet, and you can get them fixed. You mentioned EH&S, Bruce. We have a very positive relationship with our environmental health and safety people. We've spent a lot of years, especially with the AirQD centralized demand control ventilation system, working with EH&S to make sure that we're very close partners, making sure that those systems meet all of their needs, but allow us to gain energy efficiency while having a more dynamic and safe, responsive system to the conditions that are in the space. And so I think that's another thing that we, a lot of our OCX items don't usually touch that system, but it is part of what comes into our SkySpark, and that is something that we keep an eye on. But generally, yeah, I think one of the co-benefits is just catching things before it gets out of hand and before you get angry phone calls. And then I guess one other thing, and this is kind of just a general benefit of the SkySpark system, is something happens and someone says, oh, the temperature went out or the pressure went out and I lost $10,000 run of my DNA machine because, XYZ happened to the building systems. Well, we can go back and we can identify exactly when that happened, exactly what happened, and hand them that data for their insurance claim. We actually had a couple of years ago a pipe break in our chill water system in one of our buildings, and you could see exactly when it happened because the DP dropped to 0 and the chill water pump ramped up to 100% and continued to pour more water into the building. But you could see it all in the data. Now, that wasn't a good situation, but you could see exactly when it happened and exactly how the system responded through that data collection. So it's extremely powerful. And I think OCX is one way of using the fact that we collect like 1 billion data points a year across the entire campus and using that to our advantage. But there are other uses as well.
Great. I'm going to interrupt because I got a note that there's questions in the Q&A, but my Zoom is not showing them. The last question I have is from 10:56, over an hour ago. So I'm not sure why it's not posting to my view. But so Eric, do you want to?
Yeah, I can read that. Or go ahead.
Who?
Sorry. The first one's from Sozi. He said, for dew point set points, do you have humidity sensors at each building or a single weather station?
So that's a great question. So we basically have a weather station on the west side of campus and a weather station on the east side of campus. Where we're located, we kind of have microclimates across the campus, and so the west side tends to have more humidity and the east side less because it's further away from like the Newport Back Bay. And so, yeah, what we've really tried to do is start to migrate all of our buildings to use these centralized, high quality, maintained weather stations rather than having to calibrate an outside air temperature and an RH sensor that goes out of whack every 6 months at every single building. It just doesn't make a lot of sense from an operations and maintenance standpoint. So it's like, okay, let's put a quality weather station that we can pull, and then all the buildings in our Niagara front end, basically the optimization server pulls that data point in and then can make the decisions as to about what the economizers do based on that the west side and the east side weather stations.
Cool. Sorry about the Q&A vanishing there, Bruce. Next question is from Ben. For Hiroko, do students do any Python coding, use AI, or any other more cutting edge research?
So we have undergraduate students and graduate students, and graduate students have a lot of research type of projects, and they have some like optimization using Python code, etc. And some interns are focused on like Python code in the past, but it's more like, for example, like a database connections for like scheduling purpose. We have Python code to connect to the event reservation database, so we can compare the building automation systems schedules and event reservation to calculate what needs to be modified in the building automation systems. Like that type of Python code, students in the past helped our data engineer to update that code. And but otherwise, it's not like a energy optimization purpose, but we do use Python code, and students are encouraged to use those for like improving our work process. And our data scientist has a lot of data science interns that I don't oversee their works, but they do have like fault detection algorithm. They are testing some capability of detecting some anomalies in data, and that type of things are done too. So we have a very different variety of different type of student interns. But AI, maybe there's another session about it. We are just playing around and we are not actively using it, but I want to use it for maybe like through SkySpark and work orders, etc. That we have a lot of way of using AI, LLM type of AI to save some time.
That's a good selling point for our session right after lunch. Well, now, no, sorry, not right after lunch. The last session of the day, we're gonna make people stick around for AI. All right, keep going here. This is maybe sort of related, but not directly to the OCX, but maybe you can answer, folks can answer. How did you quantify the savings from new construction commissioning? Are the savings estimated or observed?
I will say the way that our new building construction is set up is that it's not commissioned the way that I personally would like to have it commissioned. And so one of the things that we're basically doing is going back and retro commissioning new buildings after they've been operational long enough for us to establish a baseline. So for instance, our new Falling Leaves Foundation Medical Innovation Building, 215,900 VAV terminal units in the building, like major laboratory building, just opened in May, but people are still moving in. So it's really hard to kind of like really commission a new building, at least from my perspective, because I've always kind of done retro commissioning. But to get the people in the building, make sure you have all the energy data, establish your baseline, and then come in and go, okay, now things are fully operational. How do we, because once it starts to get lived in, I think is really when the rubber kind of meets the road. So commissioning does happen, as part of our design build delivery method, but the type of commissioning that really gets down into the weeds of how the building's actually operating once it's occupied is what I kind of come back and follow up. So we're actually completing right now implementation on a retro commissioning of a building that was built in 22, and then we're in the investigation phase for a building that came online in 21. So we're going back, even though they're relatively new buildings, there's still plenty to find now that they've been lived in, and especially the one that was built in 22, we had a lot of issues with a heat recovery chiller, which is why another reason why our campus is a bit gun shy about those. And it caused us to change set points just to make things work throughout the entire building. And this is where a vice chancellor's resident, this is a vice chancellor's building. And so we're now coming in and going, oh my goodness, my set points are just absolutely all over the place. We need to standardize, get the sequence of operations and back to where they were. So there's even though it's less than 3 years old, there's a tremendous opportunity there to get the building back in line of where it should have been.